Are we on? Yes,
yeah,
we are.
Okay, so thank you for coming. This is the Android Tools update, in case you have not noticed. My name is Jerome Dochez, and I'm here with Tor. Despite we both have embarrassing European accents, we actually live in California. We work for Google. And I will explain the build system in more details. But before, we're going to talk about a little piece of software that lives above the build system, which is called Android Studio. So here, Tor.
Okay. And you want to switch the...
Yep.
All right. So I'm going to first do a demo of Android Studio. If you don't already know, it's based on IntelliJ, but with some additional Android stuff added to it. And the version I'm going to show you today is version 093. This is going to go out later this week. And by some simple math, you can figure out that we are 7 releases away from 1.0. Well, not exactly, because we've been known to count .8, .9, .10, and so forth. But we're actually getting very close to 1.0. So if you haven't already, now's a really good time to try Android Studio. And if you're not using Android Studio, you're most likely coming from Eclipse. And so we've tried to make that migration easy. And the reason I'm saying migration is that we're using Gradle as the build system. And Gradle sort of has a very different directory structure than Eclipse. So it's not really possible to sort of live in both worlds. You can, and I'll explain that in a second. But currently, it's a migration. So what you do is you go to import your project, and you walk through this little wizard. And when that's done, you end up with something like this, which is basically an import summary. And it's very important that you read this carefully. This is customized for each import. So for example, in this import, it's saying that, hey, your old project was not using manifest merging. And in Gradle, we will merge all manifests. So if you're using a library and that had a manifest, whatever was in it will now be in your main app. That was not the case with Eclipse. And of course, it's also doing things like dropping .jar files and replacing them with Maven dependencies. It's even removing whole source libraries. So in Eclipse, we didn't have resource libraries. You couldn't actually have a binary that came with resources. You had to copy the entire project into your workspace. We reversed that process in this import. And this is one of those reasons why if you go in Eclipse, you can actually export to Gradle, and that'll set up a special build.gradle, which lets you keep all the files in the old structure. So if you have team members who want to stay on Eclipse, you can do this. But then obviously you can't do this stuff, right? You can't actually get rid of source libraries and things like that. Lastly, this import will actually move the files around into this new, deeper Gradle structure. So you can see here, this is the project. That sort of corresponds to the Eclipse workspace. And under there, we have modules, which correspond to Eclipse projects. And then there's the source folder, and under there we have sort of the main source set, and under there you find Java, and there's your source code. So it's much deeper, and that seems pretty annoying at first until you realize why we have that. So I'm going to switch to this other project here, which is taking advantage of some of those additional source sets. And Jerome will explain this in a lot more detail. So this is sort of giving you a flavor for what we can do. So main is the source that I showed you. That's sort of where most of your source code lives. But you can set up, for example, that you want to build this both as a beta version and a non-beta version, and then you can have a beta-specific resource. So for example, you may want to change the app name. Or you could have a debug-specific manifest file, and I jumped to the wrong file. Debug-specific manifest file where you can set, for example, that you want mock location privileges that you certainly don't want in the final release binary. And all your instrumentation tests also now live inside the project as opposed to being this separate project that you had to do before. So that's sort of the source structure. And the way you deal with this, for example, to set up new flavors and so forth, is you open up the project structure dialog. This is a standard thing in IntelliJ. And here I can go in and, for example, change the Gradle version I'm using, or for each module, go in and set up that I want certain flavors, like I want a free version and a pro version, and each one can have their own package name. I can set up build types. So this is why we have beta, for example. That's not there by default. And dependencies. If you find that you want to add, for example, a Guava dependency, you just go in here and say add new library. You can search. This will search Maven Central. If I had network, I don't. I forgot to set it up. So anyway, that would show up. That would show all the matches you get on Maven Central for Guava, and then you can add it in. All right. So in the latest versions, we have this new project outline that you can use. So in IntelliJ, you can choose between different views of your project. So for example, I can choose to see just the tests. So you'll notice there's this Android view here, and that sort of helps clean up the structure of this, more complicated Gradle layout. So, for example, we have a Gradle scripts node, and so here we gather all the build.gradle files that sit in different directories in your project, so you can find them very quickly. Before this, I used to always click on the wrong file until I realized, oh, I'm looking at the wrong module. So now it's kind of simple. You can see we have these explanations on the right. So for example, local.properties. It tells us right here, that's where you set the SDK location. Likewise, Gradle wrapper properties, that's where you set the Gradle version to be used, and so on. So that's the Gradle scripts. We also pull out the manifests so you can find them easily, and the Java code, you can find it easily. And the resources is probably the best part. So if you look at resources, sort of with the old view, you had something like this, right? Lots of resource folders. Here, you can see we've sort of flattened it, so you have only the base folders, and under that, we've collapsed all the files. So for example, I can see very quickly that I have this icon right here, which exists only in the xxhtpi folder, and the launcher icon exists in all these other folders. If I look at the values files, I can see that I have 2 versions of the dimensions file, and the string file in particular, I can see here that I have my beta specific override, as well as all the translations. And so we're showing you a flag if we can figure out a rough country mapping for a given language. That's based on a lot of heuristics. So let me look at the translation files for a second. So if you open a resource file like this, you can obviously edit the resources by XML, but we now put this little, I don't want to call it a warning, information in the top of the editor saying, hey, you can edit the translations across all locales. Just open this editor. So when I do that, I get this new translations editor that we've added. And here you can see the keys, the values, and then all the languages in my app. It's kind of hard to read these words when they're collapsed this wide. So what you do is you click on the header, right, of a column, then you sort of expand it or collapse it. So if I want to look at 2 at the same time, I can do that as well, sort of based on how much space I have. And when I scroll into this translation editor, you can suddenly see that some of these things show up in red, right? So this is telling me that there's a problem with the translation, right? So for example, here, navbar description, accessibility, you can see that it's red because it looks like it's missing a key. I don't know if you can tell from where you're sitting, but there's a little red tick here that in the Italian column, we've actually not translated this. So the way you translate this, obviously, you sort of just click on a cell for a language and a key, and you can go in here and either edit it directly, or if you want multi-line text, just click on this little checkbox, and you can do multiple lines of text. You can add new keys, obviously, and you can also add new translations. So you basically type in the language you want to create. It now makes a new column. You can see it doesn't have any translations, and now all the keys are showing up as untranslated, except for these things with the check mark, which says this is an untranslatable column, right? So for example, the hashtag, I guess they wanted to put it in the key, but they didn't actually want to require translations for it. All right, so that's basically editing translations. And I showed import. We also have the new project wizard. It's sort of not hard to figure out, I hope. You just kind of walk through this. Here you can choose the min SDK version. And it used to be that if you chose min SDK version 14 or less than 14, we would add an app-compat dependency for you. In the latest build, we're adding an app-compat dependency unless your min SDK is 21 or higher, lollipop. And that's because app-compat is no longer like an action bar implementation. It is a compatibility that adds material design support even for min SDK 19 and 20, right? So, sorry, we're basically adding app-compat everywhere now. And here I can continue walking through the wizard, and you can see we have form factor support here. So I can choose that I want Android Wear support. We then let you choose templates for that as well. So let me show you what the Wear design experience looks like. Reset counter. I'm in the wrong project. Okay, I don't know what I did with that file. That's going to sort of be a bummer. Oh, there it is. Okay, so here you can see I have my layout, and I can sort of view it with the square form factor, or I can view it, with the round form factor, or I can do both, which is kind of handy because often it'll look good on one and not the other. So here, if I, add a text field in the top left corner, which it looks good on square, you can see this is not good for round at all. This gives you sort of a layout preview, but you probably want to actually test your app on an actual running device as well. If you don't have both, a round watch and a square watch, you probably want to use the emulator. So we have completely rewritten the Avd Manager. So here's the new Avd Manager. You can see it sort of starts out listing all the AVDs you have. My personal favorite is the size on disk column, which sometimes can surprise you how large it is. This sits in your home directory. And if you give your emulator a lot of RAM, it's going to take up a lot of disk space. So if I now want to do something with Android Wear, I would click on Create Virtual Device. Here I get to choose between my, my different form factors. We sort of tell you some details about the ratio and the density and all that of all these devices. And on the next screen, I can choose the system image that I want to use. And I don't have a network connection. That is really unfortunate. I should have set that up. Right now, it's showing me all the system images I have installed locally. And if I had a network connection, it actually would connect and display all the system images that's available remotely with the download link next to them. And so we're basically trying to make these tools. We've rewritten the Avd Manager. We're probably going to rewrite the SDK Manager. And so for a lot of things, you can, like, in the IDE, click, oh, yeah, I want that. And so system image is one of those things that if it has a network connection, it would display right here. So the other thing we're doing is, I mean, the secret to a fast-running emulator is three things. You want to be running with the x86 system image, assuming you're on x86 desktop, but most likely you are if you're running Android Studio. You want to have Haxum installed, and you want to use GPU acceleration. So it's not very clear that Haxum isn't installed. We actually had it in the SDK Manager, but all that did was download the installer. It didn't actually run it. So now we're actually checking here, and it's telling me, well, if I didn't have it installed, it would say, you need Haxum. Here's telling me there's a newer version, you should update to that. So then I choose my system image. And finally, I sort of get to choose, some specific details about it, like host GPU should be on by default, and so we're doing that. We also have emulator skins done now. So by default, if you make an x86, you will actually get an emulator that has the frame art around it, just like it does in the layout editor. All right, so that's the new Avd Manager. Okay, so next I want to show you the support for action bars. So previously we used to totally hack this action bar up here, but now we actually render it using various framework code to do it. So you actually get to see your overflow action and your menus. And in fact, you can even click on the overflow button to look at the menu items, and you can click on those to jump into the core. Something is broken. That's what I get. Okay, here we go. To jump into the corresponding menu file. So you can use this to sort of, see how your menu works. You can figure out how to tweak the categories to reorder the menu items. You can change whether something should be in the overflow menu. in the action bar, and so forth. And we're almost done with support for system preferences as well. So soon you'll be able to, as you're editing your XML preference files, you'll get those rendered on the side as well. And so the way these menus work is through this special tools context attribute, because the action bar menu basically needs to know what's the associated activity, and so this is how we know. You put it in the XML file. So if I take that out, you can see the overflow menus disappear. This tools namespace is really special. The packaging tool for APK for the APKs knows to rip these out. So what we do with this is we can add design time support for attributes. So here I have this text field. Let's say I want to put some sample data into it. If I put it with this Android text, and I put my name, for example, in this text field, I can sort of get some sample data. But if I actually compile and deploy the app now, that hard-coded text is in there. I don't want that. But I can actually use the tools namespace instead. And this will still, in the tool, show the value I entered. But when I actually build it, it's not there. And so this is a good way for you to put some sample data into your app for your UI design without actually polluting your running app. We also have some support for RTL editing. So here's my layout in the layout editor. And by the way, we show the layout editor by default. And that's, I think, intended for new users, because there's a lot of expert users of Android who actually prefer the XML editor. And so we recently added this option to tell us if you prefer the XML editor. So if you click this, we're going to default all new files that you open to the XML editor instead. So you can sort of tell us which mode you prefer. Because it used to be that, well, you could switch to XML, but every new file you created, layout editor. So we added that recently. It's in the overflow menu here. So this is a layout that I believe is correct for right to left mode. If I go into the render menu here, I can say, show me how this is going to look in a right to left locale. And when I do that, I can instantly see that, well, there's a problem, right? The phone number here is not right aligned like all the other things. So it's probably using left rather than start in the XML attributes. And so we have this refactoring that lets you convert to Rtl quickly. This is going to run through the whole project, look for right-to-left problems and try to fix them. And when I run this, you can sort of see it applies the refactoring, and now the phone number is corrected. If you're using the layout editor itself, it should do the right thing to begin with. If I put this on the left, you can see it shows up on the right in the other layout. Okay, let's look at some material design. So right now, this app is using Holo. And if you use app-compat, which new projects do, it's going to work well for material already. You don't have to do this thing I'm going to show you right now. But for an existing app, I need to update my styles, basically, to not just use Holo for 14 and above. For 21 and above, I want to use material. So to do that, I basically switch out Holo with material. And as you can see, that's not correct to do in a V14 file. So we have this quick fix, which lets me override this value in a V21 folder instead. So it basically duplicates that style in 21, and now we can set this back to Holo in V14. And if we now look at our layout, you can see it looks, well, it's kind of hard to tell here because we're using the dark action bar. Let me switch to just material light. You can now see that this is the material look. And in fact, one of the things you want to do with material is probably add your own splash of color. So let's go and add a color attribute, primary, color primary. Any suggestions for a color? Let's do something ugly. Okay. All right, so here we get our own splash of color. And one thing that we've just added, and it's going to be released soon, is some preliminary support for the elevation attribute, because until now you haven't seen shadows at design time. So now we have something a little bit like it. It's kind of hard to tell here, but if you look, I just added an elevation to this name here. This is not using the same code as on the device, so it doesn't look quite right, but at least you see there is an elevation there. We'll make this better. The other thing you can do here is now we have this material design look. I can also see what this looks like on older versions. So if I do go to the version menu and I say preview Android versions, I can now sort of see a rendering of this back in gingerbread look and ice cream sandwich. And the reason you want to do this is not just to see the colors, but it's also that it'll actually pick the resources according to the V folders at each level. So if I had like a resource that was overridden in V21, it would only show up in this layout, for example. How am I doing on time? I forgot to start my timer. All right. Let's look at some editing. So we have editing support for some new file types here. For example, we have render script. We also have ProGuard. Where did I put it? Not in this project. Yes, I did. All right, so you can see we have some basic ProGuard support. So like I can actually do code completion on some of these flags and so forth. But the main thing, of course, is the Java editor, and we're inheriting all the cool stuff that IntelliJ has added. So let me show you some of that. So for example, here they can figure out that since I'm null checking this, this is a potential null error since it's not guarded by the if, and so on and so forth. And they have tons of inspections, hundreds. We've added a couple that are Android specific. So for example, right here, if you're calling the array adapter thing and you're passing a string instead of a layout, we know that's wrong. And the way we're doing that is actually something that you can take advantage of in your code because it's all based on annotations. So right here, and this actually is the way we do it in the framework. So the support library is actually using all these annotations already. So if I intend for this integer here, which the compiler is perfectly happy to take as an integer, I can say this is a drawable. And if I do that, you can see that it's saying, no, you can't pass. If that's a drawable, you certainly can't call find view by ID on it. So okay, that was wrong. It should be an ID. This is an ID. And when I do that, you can see this code is lighting up because I'm passing the wrong thing to it. So you can basically annotate all your APIs with these annotations, and it'll extract that at build time into the AAR, and clients of your library will use this as well. So that's the resource type annotations. There's also the integer type annotation. So let's say I have an API like this, right, where I really want this flag to represent one of these constants, right? So I could use JavaDoc, which is what we always used to do, but then the IDE can't help you. So instead, I can use this new annotation that you can write yourself, right? So I basically I write a new annotation called navigation mode, And then I can say, I want this to pass a navigation mode, and I expect this to return a navigation mode. And the trick is, I annotate this annotation with this intdef annotation, and I can now pass in, basically, the constants I expect for this to accept. Navigation mode, standard, and so forth. So now, if someone were to call this method with any other constant, it would tell you, that's wrong, can't do that. And at that point, I think I'm going to pass it on to Jerome to talk about the Gradle build system.
Okay, thank you. Yeah. All right, thank you. All right, so we've seen what's new in Android Studio. I'm now going to talk about the build system. So this is the thing that lives below Android Studio, which is used to actually build your APKs. And I'll talk in greater details about variants, about the new manifest merger that Tor already alluded to. We'll talk a little bit about performance, because we know it's a painful subject at this point. And we'll do a little bit of forward thinking. Well, actually, there's not that much thinking. It's more like we are trying to release at this point, but we'll talk about the near future at least. All right, so the build system is based on Gradle. And one of the reasons why we decided to use Gradle to build applications was that we wanted a single source of truth. That meant that not only when you use the command line and you have to describe your build file systems, your makefiles equivalents, you could use, obviously, Gradle, but you would want to use the same thing when you build your application, either through Android Studio, like you just showed, or through maybe Jenkins or any other continuous integration service. So really, it was important for us that you describe how you build your application once, and then you can use the same description everywhere. You don't have to do it 3 times. We also wanted something that would support the Android ecosystem, so something that would allow us to build from a Ware application to multi-K applications, very complicated applications that contains a lot of feature. And so we wanted something very, very flexible that would also allow us to build different flavors of applications. Obviously, a free versus a pro is a well-known ways of building the same applications with a few different features. But we'll see that we actually provide features to actually go much deeper into customizing various versions. Also, one of the big community feedback was the ability to do code reuse. And so we try to come up with more and more facilities so that you can package your code into libraries and have those libraries being reused by your applications. So as Tor said, now we start merging libraries, manifest files into the main application manifest file. So it should be very easy to be able to reuse code when you use the Gradle plugin and its tools. All right, so first thing I need to talk about are variants. And variants really are based on 2 types of things. Either you are talking about build type or product flavors. And it's sometimes a little difficult when you're starting with the new build system to understand the distinction. So let me try to explain briefly. Build type is really about how your application is packaged. So this is how you're going to compile it. This is maybe you want to run ProGuard or not. Maybe you want it to be debuggable. Maybe you don't. This is how you want to package your app. Product flavor has more to do with what do you want to put in there. What are the features you want to see in your applications? That's like, the pro versus the free. This is the light version versus the one that your customers are going to pay for. So it's very important to understand distinction. When you create a new project from scratch in Android Studio, you always get 2 build types, the debug and the release, because some people like me, sometimes they need to go into debugger and debug their code. I know Tor never does that, but I do.
Well, with debugging, you don't have to sign it, which is kind of handy to start.
Yes. And then we also try to support multi-APK. So that's the ability now to package your application very differently in a much lighter way. And I'm going into details. So at this point, what is important to realize is that the choice of how your multi-APKs will look like will be heavily dependent on how you've defined your applications in terms of build types and variants and product flavors. So how do you define a new build type? So for those of you who don't know Gradle, Gradle is a build system. it's very different from the usual sandbox build systems. Usually, most of the build system you have an XML file or maybe a text file that describe how you want to build things, but the Gradle is a Groovy file. So it's really actually, you have the full power of the Groovy of the Java language, in a sense, inside your build file. So you can actually change a lot of things, which comes with great flexibility, but sometimes a little dangerous, so you have to be careful. But basically, you use Groovy to actually describe here how you want your build types to be defined. So you define build types, you add debug. So here, very simple. You declare a new debug and you actually initialize it with the from the stock debug one. So the GNI debug will be based on the debug one. And you just add a GNI debug, GNI debuggable flag to true for that particular GNI debug build type. So once you've done that, you've got 3 build types: debug, which you come for free; release, which also comes for free; and GNI debug, which you just created here.
And again, you don't have to write Groovy code. You can actually just use the product structure dialog in Android Studio.
Yeah, but there are people like me who use VI all day long. So.
Okay, I don't want to hear this.
So then you've got the ability to declare product flavors, and those are, as I said, more targeted to your features. And here you've got 2 flavors, flavor 1, flavor 2, no big deal. You don't get any of these flavors for free, right? So you need to declare your own flavors when you start defining different types of applications. So once you've got a product flavor and a build type, you get variants. So basically, for each combination of the product type, of the build type and the product flavor, you get a variant, and this combination will produce an APK. Right? So you've got, for instance, here 2 flavors and 2 build types: debug, release, flavor 1, flavor 2. You will get 4 variants because you've got 4 combinations, right? And you're going to get 4 APKs, which you can deploy to a device. So it's very important to understand this combination, this combinatorial factor. So if you've got multiple dimensions, multiple flavors, you're going to start getting more and more variants, more and more resulting APKs. And so it is important to understand. And sometimes all this flexibility comes with a cost. And in particular, we've realized sometime back, in particular, Tor realized sometime back that the package name, which was used or abused in different ways in Android applications, was becoming very, very inconvenient. In particular, people were using the package name, of course, to generate the R class, which is for the resource, but also the code was referencing this. So, I mean, we had this package name everywhere in our code, but it also you used to actually define how the application would be called in the App Store. And the Play Store, sorry. And so the thing is, it was very inconvenient because when you wanted to change this ID in the Play Store, you didn't want to change the code. And this overloading of the same name was becoming just inconvenient. So we decided to split it. So package name is what should remain in your code, should never change. I mean, it could change, but I mean, should be very specific to variants and stuff. Application ID is your unique ID. It must be stable. Right? It must be the one that you're going to use to deploy your application to the Play Store. So that means that if you've got a free application, you want an application ID for that free application. Your pro application do not want to use the same application ID. Right? You want to use a different one. So that, in fact, these 2 applications can live side by side. But it must be stable over time. If you change your application ID, the Play Store will think that this is a new application, has nothing to do with the old one. Sometimes describing all these variants combinations can lead to an explosion of possibilities of combinations, so it's not always convenient or necessary to build all of those. So here, for instance, you've got APIs which allow you, through this build Gradle file, this Groovy file, you've got APIs that allow you to manipulate the build system and tell it different things. And there's really a lot of things you can do. It's very powerful. There's a full DSL that you can use. Here I'm just giving you a small example where you can say, for instance, that if a particular variant is debug and flavor 1, you just don't want to build this one, you're not interested. Might not sound very interesting to do this, but when you think about, for instance, say you've got product flavors which are based on a particular version of Android. So you've got one which is for ICS, for ice cream sandwich. And then you've got another one which is for the different densities. So you say you've got densities which are XX HDPI. Well, the fact is that there was probably no device running ICS with such a resolution. So despite you've described, a variant with ICS and you've got this density in all your metrics, this particular combination doesn't make any sense. And building it, okay, it may not be broken, but it's not useful and it's going to make your build slower. So you can just ignore such combinations through this type of API. You can do many other things. You can define version for particular variants. You can do a lot of things. I'm not going to get into that because it would take 2 hours. All right, so let's talk about manifest merger. So there used to be a manifest merger in the past version of the tools, but it was a little simplistic for supporting all the use cases linked to these variants, product flavors, and build types. So we've written it completely from scratch. And this is really towards reusability in one sense, so that you can start importing libraries, like I said at the beginning, but also about overriding, customizing your resulting underlying XML for a particular variant. So you can think about, for instance, that a build type variant will actually need some specific permissions, right? You might want to be able to read the logs. Some other ones were suggested by Tor earlier. You may have product flavor specific. So for instance, your free version doesn't save anything, but your pro version is using the storage to save stuff. So you can see how each variant needs its own set of permissions. And so you have to define little XML files, Android manifest XML file that will reside in the right location inside your directory structure that Tor was showing earlier. So for instance, in the source flavor1 Android XML, Android manifest XML, that's where you would put all your Android manifest XML resources specific to that particular flavor. And like I alluded, you can have libraries. Libraries can declare, activities, permissions themselves, of course, stuff like that. So all of that should reside within the library itself, should be inside the same jar file. And so when you import it, it's going to try to merge all of this together. So the way it does that is by looking at each node of the Android manifest. And of course, some nodes have keys. So when it's going to start merging nodes, it must look at the identity of this node. It's not only the node type, like permission or activity. That's a node type, but there's also a node key. For instance, an activity has a name, which is the key, right? So when you want to merge nodes together, they must have not only the same type, but the same key. And then you can start merging them. And when I say merge, it's not like completely automatic. We're not smart enough to figure out once for all type of algorithm to merge things. We can very easily merge 2 nodes of the same type and key if they don't have conflicting attributes. So one defines a set of attributes, XML attributes, and the other one defines another set of XML attributes, no conflict. Oh, we're happy. We merge those happily. Same if they have children which have keys maybe themselves and they don't conflict, they are not the same elements, we merge them happily. But if they don't, if they have common elements, then things start to unravel, and I will explain how you can fix that. The first thing you want to understand is the priority of merging. Because now you've got maybe 10 different Android XML files that you're going to merge together for one resulting. So which one do we take first? Which one is more important than the other and stuff like that? Basically, you can think about 3 types of Android XML file. First one are what we call the overlays. These are the build types, product flavors specific Android manifest files. Those will be the most important ones. Those are the ones we start with. And then we merge the main file, which is usually located in the source main directory. And then finally, we merge all the libraries in. So this is somehow a fake priority order in the sense that this is just how we decide who wins when there is a conflict. The one which is above is supposed to be more important than the one which is below. We also do test application merging, so you can put now some Android manifest file in your Android test directory, and it will be merged with the instrumentation that we automatically generate.
And we actually use this in Android Studio too. So when you do a new from template activity, we use his manifest merger to insert the activity registration right in your own manifest file.
So Here is an example of when you start having issues with the manifest merger. So say you have an overlay and your main manifest file declaring the same activity, or maybe your application and a library declaring the same activity, and they both have an Android label. You cannot just merge like this. If you've got two nodes with the same type and the same identity try to merge and they have the same attribute, the manifest merger will generate a build error if there is nothing that tells him what to do. This is done on purpose. We didn't want to say, oh, we decided that probably you wanted to do that, and most likely you didn't want to do this. We said, you're going to have to tell us so that you know what you're doing. So here in this case, we are saying, well, you need to replace the Android label. This is the new name override you're going to be using, and whatever was below, whatever the other value was, is replaced, it's gone. This has two advantages. First, you tell us explicitly that you want to replace it. Also, say that you're consuming a library where you had to replace the label, and suddenly you now replace to a newer version of that library, and that label is not there anymore. We're still going to tell you something's wrong because you told us you wanted to replace this label. We don't find it anymore. Something has changed. You should look at it. Okay, so we are trying to be very strict about these rules so that you have no surprises about the resulting XML file. Just a peek of what you can do. You can also be very specific at the node level. So you could, for instance, an activity is a node, right, or a permission is a node. So you could define also rules that apply at that level. You could say, oh, I know that this library was defining this activity. I don't care about it. I want to replace it completely with this new node. Do not try to merge. That's it. That's my new node. You can be strict, where you could say, I am the node of this particular type and this particular identity. Nobody else below me should declare it. And if there is one, I want to know. So again, that's this idea of being very strict about not having any surprising merging happening. You could say, I just want to merge the attribute, forget the children, no XML children being merged. You could say, I want to remove a particular activity, for instance. So say you're merging a library, and that library comes with 3 activities, but there's only really 2 that you want to consume. You could say, this particular node type and node value and node identity, I want to remove it. So that activity will just be removed, and it won't be in the resulting XML. Or you could remove them all. At that point, you just say, remove all permissions, remove all activities. Whatever you want to remove, you can remove all, and then we don't care about the identity, just the types, okay? So as you can see, it's very powerful. There's even more features that you can have. For instance, we do value injection. So sometimes, it is interesting that you do not put the application ID inside the hard-coded inside the XML. You would like to use the one that is going to be actually used to define the application identity in the Play Store. So it's very important to do that through injection so that you don't have to change your code each time you change variant. We provide a few injections for free, like the package name, for instance, but you can have more. You can define your own placeholders. You can define your own keys and values. So the key goes into the Android manifest XML, obviously, just like application ID at the very top. And then in the build, in the Groovy build.gradle, you can then define those particular key value pairs. And here you've got a default one, and you've got a product flavor, which is called, well, actually, I probably shouldn't have called free and pro. I think I made a small mistake here. But basically, you get the idea that in the free or the pro, I would have a different activity label. Okay, that's a good and fast way to really provide added value to your pro consumers. You see the activity name has changed, and you charge them $5 for it. All right, so more build config injection. So as you may have guessed by now, I'm French, and we are naturally lazy. But not everyone is like this, and some people want to have wants to be able to do things easily. And so sometimes all this flexibility of flavors and product build types and whatnot, it's too difficult for people, and I understand that. So I think that if you want a quick way of saying, I want certain things to happen in certain conditions, you can do that very quickly through what we call this build config stuff. So basically, you still have to declare your build configs, your product flavors, sorry, but you do not have to move your code around, right? So the correct way, what Tor would do, the correct way of doing things would be to move the code for your paid product flavor into a source set, a directory which is only compiled when you're switching to the paid flavor. But if your code is very complicated, maybe not so well written, or maybe it has evolved for 5 years and it's not easy to tear out stuff, one easy way is to just declare those build configs, and then in your Java code you say if this, else that. Right? Very easy. You don't have to really change your code. Instead of having to move things around, you can just do that in 2 minutes.
And I think that those fields are made final, which means that the compiler will actually drop all the stuff inside the if it's false, so you actually aren't really paying a price for it.
Yeah, but we should probably not encourage people to do this, though. All right, another thing you could do is to have res values. So you could define in your build.gradle, you could define these different resources, and then we generate automatically the resulting resource file. So again, that's the way to do things differently, very easily, without having to necessarily put very specific resource files in a directory which is specific to a particular build flavor or product flavor. With the latest Android release, the Lollipop, we've got a few features that I want to talk about, and these are important ones. So first we'll talk about splits and then multidex. So splits is supported by Lollipop, but not by the Play Store yet, so you can't really use it at this point, but you can start developing with it, you can start testing and being basically ready when it's going to be supported. But it's not supported yet, so it's coming. One of the things you can do, so we've been, let me back up a little bit. In the past, we've had fat applications, right? You've got APKs that can support all possible densities and all possible hardware configuration, and that created really, really fat APKs that only a subset of a particular configuration would be used on a particular device, right? And so they made things slightly better with what we called multi-APKs, where you would decide that you want one density and one ABI, but that still kind of was containing the entire application. So you would have one APK that would be for one particular density, would still contain the entire app. Then the same application for a different density would still contain everything else, all the classes.dex, everything would be duplicated between those different APKs. The new things that we are trying to move forward is this concept of multi-APKs with multi-splits, where you've got one main APK, which is your application, the common things of your application, in particular the classes.dex and stuff like that. And then you've got some smaller APKs which are specific for each flavors or for each densities, for instance. So you've got the different densities, different ABI, maybe different languages, APKs. And those do not contain the classes.dex, for instance. They just contain the resources specific for that particular density. So when you want to install an application now, it's not going to be only one APK anymore, right? You're going to have that particular main application APK plus a certain number of sub-APKs, which are going to be very specific to the deployment target. Might be a XX HDPI in French for ARM type of configuration. So you got 3 different smaller APKs, the French resource, the XX HDPI resource, and the ARM resource. And all that gets, with the main APK, those 4 APKs get deployed for your application to run correctly on a particular device. Now, with the new new Art runtime environment for Android, we now can support much more easily multiple DEX files, the above 65K method limit. So it's much easier at this point. You can just set this particular flag. Of course, again, because it's a lollipop feature, this is something that you can only target for applications that you want to run only on this particular version of index files inside your APK that will be natively loaded by Art. So it makes things a lot easier than it used to be. All right, let's talk a little bit about performance, because we know that it's a painful subject from where we have been starting when we started the project. And there are things we can do on our own, and there are things that we cannot do on our own, so I'll talk about that. So one of the first things that we did, or that Tor did actually, was the resource shrinking. So I'll talk about that, PNG Cruncher. But before I go into more specific tools update, I want to talk about the common work with Gradleware. So Gradleware is the company behind Gradle, and we are working very closely with them because we have realized that one of the issues we have with performance is about project loading. So when you've got, Tor was alluding it, when you've got a project that has multiple variants, maybe that has also a lot of library dependencies, many modules and all that kind of stuff, your project starts to grow a lot, maybe 100 modules, something like this. Gradle needs to have an in-memory representation of this particular project with all these modules, with all these dependencies. And that takes time, and it has to do that every single time you run something. I mean, you can reuse a cached copy from time to time, but it takes time. And so it's not something that because we are just Gradle users as well, even though we've developed a lot of plugins, we are just Gradle users. It's not something we could easily work on our own. So we started working a lot with Gradleware. We are very close relationship with them, and we are really trying to fix that. And they are really trying to fix that too. So I think there will be very, very soon big improvements there. On the things we can do on our own, we worked on first resource shrinking. Actually, Tor, you can talk about it since you did it.
Well, this is not really a build thing. In fact, this makes your build slower. The main thing here is that, in the past, you probably pro-guarded your app. That's one way to get around the 64, 65, 64K method limit. Mm-hmm. But that removes your code. But if you, for example, are using Play Services and you're using it, let's say, only for AdMob because you want ads in your free app, you're still going to be loading in Play Services, and it comes with like resources to do Google login. And not to pick on Google login, I love when apps use that. But that means your app is including the Google Plus sign-in button asset, which you don't really need. So even though the code gets shrunk, your resources don't. So what this feature does is it looks at your app after it has been pro-guarded, right? So it knows what code is actually remaining from those libraries, and based on that, it removes all resources that your app doesn't actually use. So that's it. Basically, makes your app smaller.
App smaller, meaning it will download faster.
Yeah.
All right. Another big thing we've developed lately that I did was the QCruncher. So PNG files need to be crunched to be able to be packaged, and it used to take a lot of time. And so we came up with basically a multi-threaded, based on a queue type of architecture where the build system will just push into this queue all the PNG files you need to crunch, and then we'll crunch them using a pool of native crunchers. So initial numbers, about 10 times faster, so it's pretty good. It depends, obviously, the number of PNG files you have. This is for 500 PNG files, so it depends on your project.
Well, that sounds like a slam dunk. Why is it opt-in?
Because I have very, very little confidence on my own code. So, it's multi-threaded and that kind of stuff. So basically, it's an opt-in at this point. But, if we receive no more than 1,000 bug report, we will turn it on next time. Okay. Promised. All right, next step. So one of the things that we know we are still missing, and again, it requires a little bit of work in conjunction with Gradleware, with the Gradle infrastructure below us that we can't really freely change. It's variant publishing. So say, for instance, you have a release and a debug version of your application, and you have dependencies on libraries. Well, it makes sense at this point to say that when you want to publish things, you would want to publish a debug version of your application with a debug version of your library. And at this point, it's not really possible. So you can obviously have a debug version of your library, which you will actually debug on its own. It's not going to be easy to have a debug version of the library being packaged automatically into the debug version of your application and debug the entire thing. So you can do it, obviously, but you have to package things in debug mode and consume things in debug mode. You have to hardcode basically that you want the debug version of your library. So we know it's not optimal. We're working on it. Again, it requires some changes below us that we're hoping to get pretty soon. So once this is available in Gradle, we'll make it work. I already talked about the performance stuff. At this point, we're going to try to become more gentle with modifying the DSL. So the DSL is the language that you guys use to actually, declare your build types, your product flavors, and so on. And we've been pretty open.
Well, we felt free to change it incompatibly, and we've had, the IDE basically and the Gradle plugin in lockstep saying if you get this version of the plugin, you also need this version of the IDE, and vice versa. We haven't really done the extra work of doing cross-compatibility, but that is something from 1.0 we hope to do, right? Where you are free to update the IDE without touching your builds, and vice versa. You could touch your builds and leave your IDE in place. Because it used to be with Eclipse, when the build was part of the IDE, if you wanted the new IDE features, your builds would change, and sometimes, that was not what you wanted.
Right. So we hope we're going to do much better from now on, not only between the integration between us, which you probably don't really care that much, except of this little inflexibility of version.
But also, if we do change it, we will try really hard to do help in the IDE to do it automatic, to migrate.
Yep. And we're also going to try to stabilize the API that you guys can use to declare and to manipulate variants, right? The stuff I was showing earlier. Again, we might have to change in the future. We'll try to make it backward compatible with deprecation warnings for a while and stuff like that. So API stabilization is very important right now. We're going to try to make it stable, basically. Now, of course, the Belgian beers are not helping, and we may be completely delusional, but we think we're pretty close to 1.0. And so you guys should expect the RC builds coming up very soon. If you are users, please use the RC build as soon as you can, because it's always better than having to do an urgent patch. But if you're not using yet this new build system, if you're still using Ant with Eclipse, for instance, now is a good time to switch, because as I said, the API is becoming very stable. We think we're getting ready. We think you have many more features than you used to. So it's a good time to start. We can't guarantee there are no bugs yet or left, but since it's NRC, I think it's a good time. I think we're pretty close. So please download everything. It's all out. It's all available, and I think we're done. I think we have a few minutes for questions. Thank you for coming again.
Yeah, thank you. Do we have any questions? Yes.
I can see.
Okay, I think the question was about the resource type annotations. They're in the support library. And the question was, can you get those warnings with Gradle on the command line? No. And the reason for that is that we are totally piggybacking off of IntelliJ's very good data flow stuff, and that is running only in the IDE. That is not stuff that we can actually run on the command line. So that's unfortunate. One day we might be able to do it, but there's a couple of specific inspections that you have to only get in the IDE. Yeah. Any other questions? Yeah.
I have a silly question. Do you guys know any incompatibilities with Java? Because I have my Android Studio crashing a lot, and I don't know if it's related to my Java version.
All right, so the question was, are you aware of any incompatibilities with the Java runtime and the IDE? I am aware of some crashes on Java 8. One I saw was if you are using an Asian input method, that causes a crash or something like that. What I would do if you see a crash is switch to a different version of the JDK and see if it runs better. I also think I read somewhere that there's some other known crashes with Java 8. So with Java 7, I'm not aware of many crashes there, no.
Which operating system?
Oh, Yosemite. That's the new one, right?
Yes.
Yeah, so then there's probably some problems.
We have not upgraded yet.
Yeah.
Google didn't let us do it yet.
Yes. Any other questions? I can't actually see because of the
It's
lights.
difficult. Yeah, but no, I don't think there is. Well,
Oh, there's one up here. Yeah.
Using the ultimate version of IntelliJ, and you port back your studio, right?
Yeah, so the question was, he's using Ultimate Edition of IntelliJ. Will they port these changes? And the answer is yes. So they seem to do it pretty rapidly, right? So they are doing. I think they just released IntelliJ 14, and IntelliJ 14 has a lot of recent changes. I think they tend to do it like every couple of weeks or something like that. But now that it's stable, you might start needing to look in the 15 EAPs for future changes. But again, since we're very close, I think it's probably easier for them to not get these massive unreliable changes from us. Things are going to sort of die down, and so I would think that very soon you would have it. And I think that IntelliJ 14, already has a lot of the features here. Like I suspect the translation editor's in there, and maybe most of the Avd Manager. Yeah. Any other questions? You have to. Oh yeah, over here.
How has your experience been building Android Studio for both IntelliJ? Easy or difficult? How does it compare to
well, he looks 10 years older, but otherwise.
So the question was, what was our experience developing Android Studio on top of IntelliJ? I've worked on plugins for many different IDEs, and I got to say IntelliJ is by far my favorite. It was, it's very, very nice. APIs are nice and clean, and I think that they feel more free to change APIs than other IDEs have. So the net result is that it might be, harder to be a plugin author and keep up to date, but the net result is that the APIs are just very clean. You don't have multiple compat versions of the interfaces. They just seem to change. And so, yeah, no, it's been very, very good.
It's developed with pleasure at all levels.
Yes. No, very, very satisfied customer. Any other questions? Yeah, up here.
Are there any efforts to support more modern languages, like, for example, Ruby within Google? I mean, there are efforts to bring Ruby to Android, right?
All right, so the question was, is there some sort of effort within Google to bring other languages to Android? I'm going to choose not to answer that.
I don't know. Honestly, I don't know.
Yeah. Sorry.
I think you should talk to the Android folks more than the tools.
Yes. If there's any other hands, you have to actually yell out something because we can't see.
Well, I think we have only 2 minutes left anyway.
All right. Well, thank you all for coming.
Thank you.
Well, in the black of night, murder.